Hello everyone, welcome to my YouTube channel. I am Vikas from Sri Venkateshwar College of Engineering. Today's our topic is Rook Polynomials. An introduction. Welcome to the presentation on Rook Polynomial. This fascinating area of the combinations offers a powerful tool for solving a problems related placing non-attacking rooks on chessboard. While rooted in the game of chess, applications extend for everyone, touching upon various fields like machining problems and beyond. Over the next few cards, we will explore the fundamentals of a root polynomials, delve into these combinations, and uncover this derives application prepared to see how simple game pieces can unlock complex mathematics solutions. What is rook and chessboard referring? A moment. Moving any number of sequence horizontally or a vertex along with this path is clear. Attacking a rook attacks any piece on the same row or column. Two rooks attack each other if they are shown share two row or column. Non-attacking rooks are non-attacking if no two rooks shares the same row or column, ensuring they do not doesn't treat each other. Before we divide it into rook polynomial, let us quickly refer to our understanding of the rook pieces in a chess. The rook is powerful pieces capable of the movement of any numbers of a sequence along with the ranks, that is row, and if fields columns. The unique movement defines its attacking capability in rooks, controls every sequence in its current row and column. For our purpose, the key concept in non-attacking rooks. This means that when we place up multiple rooks on board, no two rooks can share the same row or column. This constraint is fundamental to problems rook polynomials help us to solve. The problem's non-attacking rooks placement. Combinational challenges. Permutational algorithms generalization. How many ways can we place k non-attacking rooks on any m into n boards? The problems related to permutations has each rooks occupies as a unique row or column. Generalization. What if the board has creation forbidden sequence? The core problem that Rook polynomial address is determining the number of ways placing k non-attacking rooks on given board. This seemingly simple question quickly becomes complex, especially when considering board of various sizes, those with restricted positions. Think of the permutations problems for each rook. We must choose a unique row and unique column. The real challenges emerges with the board. Its simple rectangle, rectangle, but the rather has certain sequence where rooks are forbidden. This is where the power of rook polynomial truly shines, offering a sympathetic way of ensuring their arrangements. Defining the rook polynomials a formal approach. This is a formula where we are going to apply in the row or columns. The root polynomial is denoted R B of x for given board B is generating a function that encodes the number of ways to place non-attacking rows. Each terms R k of B in the polynomial represents the number of ways to place exactly k non-attacking rook on a board B. Here B refers to the specific configuration of board, which could be stands, chessboards, or board with executed sequence. The highest power of x in the polynomial will be maximum number of non-attacking rooks that can be applied on board B, which is limited by the smaller dimensions of the board. Computing the root polynomial example and techniques. This is an example for we taken a board size, number of ways to place rooks, number of ways to place two rooks, a rook polynomial. Computing a rook polynomial can be done through a combining combination of an enumeration and recursive technique. For a small boards, we can manually count the arrangements. For example, and 2 into 2 board, there are 4 ways to place one rook and 2 ways to place 2 non-attacking roos. More complex boards offer utilization recurrence relation. A common approach involves picking a sequence and considering the two cases: either a rook is placed on that sequence or it is not. Then this divides the problems into a smallest, more manageable subproblems, allowing for a systematic calculation of the polynomial conference coefficients. Rook polynomials and forbidden positions. Constraints handling, inclusion, exclusion, partial applications. Rook polynomials are particularly useful for the problems with forbidden positions on the board. The principle of includes exclusion is offering emulating to handle these constrictions calculations and the number of arrangements by subtracting those that violate the rules. This extends to scenarios like assigning tasks to people where the same assignment are not allowed. One of the most powerful applications of the rook polynomial is the problem involving a board with forbidden positions. These are the sequence where the rook cannot be placed. This adds a layer of complexity to the counting problems as we must execute arrangements that place a rook on that forbidden sequence. The principle of inclusion exclusion is the key technique used in the construction with a rook polynomial to shackles these sensors by systematic adding the subtracting arrangement that violates the constraints. We can precisely determine the number of varied placements. This concept has a significant practical implications beyond the chess, such as such in scheduling or arrangement problems where certain combinations are not permitted. Applications, matching problems and beyond. Assignment problems, network flows, cryptography, bioinformation, formatics. While rooted in the game, Rook Polynomial finds a surprising utilizing in the diverse fields. This applied to ensuring permutations with a specific constraints, making them invaluable for solving various matching problems where the elements for the one set need to be pairs with elements from another subject to certain configuration. Everyone directed mashing their underlying combinatorial principles contributes to understanding network flows where resources are optimally distributed. Everyone is abstracted fields like cryptography and bioinformations. The synthetic counting and arrangement principles derived from a root polynomials can play a role in developing robust algorithm and analyzing complexity data structures. Conclusion: the power of root polynomial fundamentals rules versatile applications problem solving insight. Rook polynomials provide a robotics format for ensuring a non-attacking rook placements. This utilization extends far beyond just solving complex combinatorial problems in various domains. Understanding rook polynomial ensuring our ability to approach and solving problems involve the permutations and constraints. In conclusion, rook polynomials are the more than just a combinational crucial. They are powerful mathematical tools that offers a systematic and aligned way to enumerate arrangement of the non-attacking rook every even on a boards with indirect forbidden positions. This ability to handle constraints and permutations making them broadly applicable for this theoretical graph theory to practical application in the logical and computer science. The principle embedded within root polynomial provides valuable insight into problem solving by grasping these concept. We going to deep applications for the intercombinations of the mathematical mathematics and its capacity to model and solve the real world challenges. Thank you guys for watching my video.